Hey guys, so here we've got one of the more challenging questions in the course. It's how many five-digit numbers include five fives, but include a five, at least one five, but exclude eight. All right, so it has to be one five, could be two, could be three, could be four, or five fives, but it can't have an eight in it. All right. Well, how are we going to approach this question? Turns out that it's quite challenging if you try to build numbers that include specific digits. So I just want to make a statement here. Okay, building numbers that include specific digits is difficult. Okay, whereas building numbers that exclude specific digits is easy. So, keeping that in mind, what I want to do is always the easy thing and not the difficult thing, okay? And so, let's change the color of this to, I don't know, some other color. There, we'll highlight that in yellow. We don't want to do the difficult thing. We want to do the easy thing, all right? So, what we're going to do is we're going to start by building all numbers that exclude eights. Okay? And then what we're going to do is we're going to subtract from that. That's going to be too many numbers. Okay? First of all, let me just say this is going to be too many numbers. It's going to have numbers that don't have eights, which is perfect. But some of these numbers that I build here, they're going to have fives, and others won't have fives. But I want to make sure that all of the numbers I build are including a five. So what I'm going to do now is I'm going to build a set of numbers that is way too large. But then if I subtract the perfect amount of numbers, I'm going to be left with the numbers that I'm looking for. So I now must build, right, all numbers that exclude eights and fives. That exclude eights and fives. Okay? I'll spread this out here like that, and I'll spell that one hopefully correctly. There we go. So I'm going to build this set of numbers. It's going to be a big, big number. And I'm going to subtract from it this set of numbers right here. Okay? So let's go ahead and attack this. All numbers that exclude 8. Well, there are 5 digits in my number. So according to the multiplicative counting principle, I have 1, 2, 3, 4, 5 events. And I'm going to multiply them together. And so I have to choose 5 digits. Well, of the 10 digits, 0, 1 through all the way to 9, there are 10 of them. How many am I allowed to put in the first position? Well, remember, I don't want 8, so that I'm going to, 8's not an option. And also, 0 is not an option. Okay? So 8 and 0 are not an option. So how many are left? 1, 2, 3, 4, 5, 6, 7, and 8 options are left. Okay. So now I'm going to choose the second number, or the second digit in my 5-digit number. Well, what options do I have? Well, I guess I can have a 0 in the second position. But I can't have an 8 because remember, I'm building all numbers that exclude 8's. Why? Because my final number can't have an 8 in it. So all the numbers that I'm going to build here are having no 8's. So how many options do I have for the second position? I have 9 options. 1, 2, 3, 4, 5, 6, 7, 8, 9. You can see up here there's 9 numbers. Okay. And then the same reasoning goes for the third digit, the fourth digit, and the 5th digit. So here, what I've done is I've successfully built a set of numbers, which, by the way, if I calculate this out, it's 52,488. 52,488. That's how big this number is. 9 times 9 times 9 times 9 times 8. Okay? And if I subtract these numbers here, I'm going to be left with, conceptually, equals all numbers that have no 8's but have 5's. So all numbers with no 8's but have 5's. Okay, let me make this a bit bigger. That. And that's what I'm trying to build. 5-digit numbers that include a 5, but exclude an 8. Okay? Or have, I should say, at least one 5. Have one or more 5. Okay? So how do I build all numbers? So what I'm doing right now is I'm going to try and build all numbers that exclude 8's and 5's. Okay, so let's build them. That's going to be a 7 for the first, because I remember I again have 5 events. And how many options do I have for the first number? Well, I can't have a 0. I can't have a 5, and I can't have an 8, because remember, I'm building all 5-digit numbers that don't have an 8 or a 5. Well, I've got 1, 2, 3, 4, 5, 6, 7 numbers left up here. Count them, there's 7 digits left up there. And then I've got 8 here, 8 here, 8 here, and 8 here, because the 0 is eligible for the second, third, fourth, and 5th digit. Okay. This number, 7,880, it's not 7,888, so it's actually 7 times 8 times 8 times 8 times 8. It happens to be 28,672. So 28,672. Okay? And so I'm left with, finally, the actual number of possible ways of building that, or 52,000. Let me calculate it now. Minus 28,672. So 28,672. Hopefully I typed in those numbers right, is going to be 23,816. And that's our total number of ways, okay? Now, I imagine maybe some folks are having difficulty imagining why this looks, or why this ends up working, okay? Well, what I want to do is I want to take this batch of numbers here, right? I'm going to change it to, I'll change it to a different color. Let's go with brown here, and we'll go like that. This batch of numbers actually contains 2 sets of numbers. And this batch of numbers here, let me just go with like a dark teal. That's just a very nice dark teal, is a set of numbers. So in this set of numbers, the 52,488, there are 2 types of numbers. Numbers that have, let me go back to my brown here, okay. 8's, no, but 5's, no. And then there are some that have 8's, no, and 5's, yes. Okay? Why do I write 8's, no in both cases? Because remember, the initial condition for this 8 times 9 times 9, this number here, was that I said there are no 8's. So there are 2 types of numbers. Numbers with no 8's and no 5's, plus numbers with no 8's and with 5's. So over here, I've this teal set of numbers. All of these numbers have no, or 8's, no, and 5's, no. I built this blue set of numbers such that it has no 8's and no 5's. So it's basically this concept and this concept are equal. So if I take something plus something else and I subtract the same thing, I'm left with that other thing. So I'm left with, if you can see here, this concept, which is no 8's, but yes 5's. Okay? Let's do this in a more simple situation, just so you can see that it actually works. Okay? So instead of a 5-digit number, I'm going to build a 2-digit number with no 8's, but including a 5. Okay? But includes a 5. All right. When we simplify a procedure like this in an attempt to sort of understand why our above formula works, what we want to do is we want to actually also be able to list out all the possibilities and then verify numerically that both ways work. If I list out all the possibilities, I know I have the right answer. And then if I do this formula up here and I get the same number in both cases, then I know my formula works. The problem with this number is 52,488 possibilities minus 28,672 possibilities. It's far too challenging to list out all the possibilities. So let's just try it with a 2-digit number. I can easily list out all the possible numbers that have no 8's but include a 5. Well, let me write some of them over here. 0, 5, 1, 5, 2, 5, 3, 5, 4, 5, 6, 5, 7, 5, 8, 5, and 9, 5. All of these have 5's, but the problem is this is not a 2-digit number, 0, 5, and this one's no good because it has an 8 in it. So I don't like those numbers. Let's list out some of the other ones. Well, the ones that start with a 5, so 5, 0, 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6, 5, 7, 5, 8, and 5, 9. Did I get that right? So I'm going to cancel. Oops, let me make that purple. Oops, or not purple, orange. Those two. Okay? Let's see, 1, 2, 3, 4, 5, 6, 7. Oh, I forgot. 5, 5 here. 5, 5. Here, let me redo this, guys. Sorry. I can't apparently count by 5's. 5, 5, 6, 5, 7, 5, 8, 5, and 9, 5. So I canceled out these two. So sorry, guys. This one and that one. Now in the 50's, I got 50, 51, 52, 53, but I'm canceling 55. The reason being is because I've already counted 55 over here, and I don't want to count 55 twice. So I'm going to cancel this one and this one. So as a result, I'm left with 8 numbers in the first column, 1, 2, 3, 4, 5, 6, 7, 8, and 8 numbers in the second column for a total of, there's 16 numbers. Pause the video and check it out. There's 16 total numbers here. Okay, well, let's do what we had in the previous formula. So I'm going to build all 2-digit numbers with no 8's. Well, that's just going to be the same as up here, 8 times 9, but with no more 9's. I'm going to stop there. It's 8 times 9 because I've got 8 options for the first digit because I can't have a 0 or an 8, and I've got 9 options for the second digit because I can't have an 8. And now I'm going to subtract all 2-digit numbers with no 8's and also or nor 5's. So that's going to be a 7 times an 8. Why is it a 7 times an 8? Well, the same as above, because if I don't want a 5 or an 8, well, in the first position, I can't have a 5, an 8, or a 0, meaning there's only 7 possibilities. And in the second position, I can't have a 5 or an 8, meaning there's only 8 possibilities. Well, 8 times 9, last time I checked, was 72, minus 7 times 8, which is what, 56. 56. And now 72 minus 56, I believe, is 16. Why is that awesome? Well, because when I listed out all of the possibilities, I noticed that yes, just forming a list there's only 16 digits. So what I'm doing above works, if it works for 2 digits, it should work for 5 digits as well, okay? That's basically how you do it. Now, there's one last sort of mystery. Why is it that building numbers that include specific digits, why is it difficult? Okay, why is it difficult? I'm going to move over here. And I'll just say, because if I want to, let's say I want to build a number that includes a 5. Well, I need to build it into various cases. So case 1, well, the first case, I could have exactly 1 5. Or case 2, well, I could have 2 5's. Case 3, I could have 3 5's. Case 4, I could have 4 5's. Case 5, I could have 5 5's. So in the end, I already have to build it into 5 different cases, okay? And then of the case 1, where I have 1 5, I actually have to consider all of the numbers that have 1 5 in the first position, and all the numbers that have a 5 in the second position, and all the numbers that have a 5 in the third position, fourth position, and the fifth position, and so I end up having to multiply it by 5, okay? Over here, case 2, I have all the numbers that, well, in the end, it becomes very, very challenging. I have to use a series of fundamental counting principles with something called the binomial theorem, which we'll use later on, but for the time being, it's actually easier to do it this way. Anyway, that's all I have to say about that one.